Hi everyone, my name is Vikas Surya, and in this project I will work on clustering restaurant and performing segment analysis using Zomato dataset. This is the GitHub link where you can access the project, and there is the dataset, the two datasets. So there are the libraries which I am using over here, and I am mounting my Google Drive. After that, I am storing uh, the two different variables, metadf and reviewdf, and this is the first five views of metadf, and this is the first five views of uh, reviewdf. Uh, then uh, dataset row and column count. There are the shapes of metadf and reviewdf and dataset information. Okay, there are the information of both variables. Uh, Now I am checking duplicate value where these are uh, these are present or not. There are 36 duplicate values are present in the visualization of missing value of metadf, and the visualization missing values. This is the visualization of missing value of metadf, and this is the visualization for review df. Uh, then understanding your variables. Okay, there are the variables of both the datasets. This is the description of metadf, and this is the description of review df. Now checking for unique values for every variable. If any, then you can see the unique value for both the dataset. Uh, Data wrangling. Now coming to data wrangling part. First we have changed the cost function from object to integer. Then I have removed all null values, if any, present in reviewdf. After that I have replaced reviewdf reviewdf of rating, which is likes, and after that I have changed the rating to float. Extracting details from metadf, uh, and these are the rate, rest of the manipulations which I have used over here data. Mm, and these are the data from extracting time, year and month, and data visualization, storytelling, and experimenting with charts, understanding the relationships between variables. Um, okay, I have made um top 10 affordable restaurant by cost and top 10 costier restaurant by cost. And now coming to chart 2 visualization code. Uh, this is top 10 cuisine by restaurant count. Uh, Now coming to chart 3, top 10 reviewers by maximum followers, and this is the top 10 reviewers by maximum followers. And coming to chart 4, top 10 restaurant collection. These are the top 10 restaurant collections in chart 4. Now coming to chart 5, top 10 reviews by average rating. These are the average reviewers rating. Now coming to chart 6, here I create a bar graph, and then create a bar plot. Then I set XY labels and then titles, and here is review count by months. Now coming to chart 7, visualization. Mm, Visualization. Combine the top 30 reviewers into single text and creating a word cloud with specified parameter. Here it is. Now coming to chart 8 visualization code. This code helps identify who are the most active reviewers On the Zomato platform, it calculates how many reviews each person has written and then visualize the top 5 reviewers by review count. Uh, Now coming to chart number 9, uh, uh, top 10 cuisines by average cost. And now coming to uh, chart number 10, visualization, correlation, heatmap. This correlation heatmap visualize how numerical features like rating, votes, and cost for two are related to each other, and health patterns such as whether high-rated restaurants tends to receive more votes or charge higher price or not. Now coming to hypothesis testing, uh, it helps you decide whether cost for two is a significant predictor of how customers rate restaurant or not. And hypothetical statement second, this test helps you to assess whether work with like more followers tends to give higher or lower rating. Hypothetical statement third, now the statistical test performed to obtain the n values is the chi-square test of independence. Uh, okay, let's moving forward. Now features engineering and data pre-processing. First, handling missing values, filling missing rating or cost with missing values. Second, handling outliers. As data is very less, will not do outlier detection. Uh, then second, uh, the third category, encoding. Uh, I'm sorry, categorical encoding is the process of converting text into numerical format. Uh, and then fourth, textual data pre-processing. This process cleans and prepare raw reviews text from tasks like sentiment analysis and textual vectorization. Uh, uh, Expand contraction. Uh, it converts words to standardized language. Uh, can't is converted into cannot for better understanding. Uh, Now coming to lowercasing, it convert into lowercasing, then remove punctuations and removing URLs and removing words and containing digits, removing stop words and removing white spaces. Uh, Now coming to tokenizations. Uh, These break down the text into chunks. For tokenization, I use uh, NLTK and PunkTab. It's PunkTab. This is the resource which has pre-trained tokenization tokenizer. And now coming to text normalization, uh, it cut down the words into its original form. And for lemonization, uh, I use WorkNet Lemonizer. Lastly, a text vectorization. For this, I use IDF vectorizer, uh, a term frequency and inverse document frequency, feature manipulation and selection. First, feature manipulation. It manipulates features to minimize features correlation and create new feature. Uh, Now coming to data transformation, there are all transformation which are used here. Now coming to data scaling, I used standard scalar and numerical column. Variables names are cost, total cuisines, and average rating. And scalar fit the cluster dummy from numerical columns. Uh, dimensionally dimensionality reduction. Uh, I am using PCA to reduce the dimension and train the model. Now you can see uh, uh, variance and number of component. Uh, the principle of PCA full form is principal component analysis. Data splitting. Data splitting split your data to train test and handling imbalanced dataset. Lastly, machine learning model implementation. First, I am implementing k-means. Now you can see Elvocaro over here. Then silhouette score. Uh, in silhouette score, firstly define cluster range 2 to 9. Then apply k-means for each value of n cluster. Then computes overall silhouette score, then plot the silhouette score per cluster, then plot PCA 2D scatter with cluster labels and centers, mark clusters with number at their centers, and this is the moving forward, visualizing the cluster and the data point in each cluster. Now you can see 6 cluster, and this code create the data frame, and this code merge the cluster label from k-means into the original restaurant data from further for further analysis. Back to normal form log during transformation, counting cluster observation. This code remove extra tailing space from cuisines after exploited. Uh, Lastly, printing cuisines a list for each cluster. For model 2, we use LDA, latent dit-rich allocation. We plot silhouette score. These lines prepare normalized topic word and document topic distribution from LDA output, which is essential for understanding visualizing topic models using uh, pi LDA wise. Plotting the cluster top 30 terms. This is the graph, and review sediment prediction. These are the review sediment prediction. Uh, Now uh, this create colorful words, a cloud that visually highlight the top 100 significant words for each LDA topic, and these are predicted sentiments. Now coming to supervised machine learning, here we define functions to calculate score. then calculating score, get the confusion matrix for both train and test, add labels to the plot, add values inside the confusion matrix, add titles and XY labels, and this is the result. And lastly, logistic and XGBoost algorithm. Here we use logistic regression and XGBoost classifier, and this is logistic regression grid search CV, and this we are importing. And lastly, we train the model and record the result and set name of the classifier as index levels. And this is ROC AOC curve. Here is logistic regression AOC equals to 0.919 and Exibus classifier AOC 0.923. Conclusion: firstly, optimize cluster topic modeling, then model performance, improved precision, then enhanced recall, then balanced F1 score, ROC, AOC significance, model deployment, future uh, prospect, and implement on business data transformation. And thank you.